Okay, in today's lab, we are going to see multiplexer encoder design. Multiplexer and decoder we already saw in the last class, and also we are going to see some applications of multiplexer, encoder and decoders, right? Okay, so this was the decoder which we did it last time. I have only modified a little bit out here. I have given an additional enable pin. Okay, so whenever the enable is 0 out here, you will find the output, all the output will be 0 irrespective of what is the input. Okay, so that is the reason, and if you see here, this program has been slightly modified. So you have an input, okay, that is an 3 input is an 1 2 3, so it's an 3-bit input, and you have a single bit enable input, and output is 0. So as long as enable is 1 out here, okay, as long as enable is 1 out here, so if the input is 0 0 0 here, this top line will be 1, and if if input is 0 0 1, the next D1 will be high here, and if the input is 1 1 1 out here, D7 will be high here. So in the output side, only one line will be high at any given time, okay, based on the input. So that is how the decoder, we learned about the decoders in the last class also. Okay, only difference out here is I have an enable pin also out here. So now I don't have to write all the conditions for enable is equal to 0, it will be out here, because I have set for all these 8 conditions. If enable is equal to 1, these are the things available. Okay, I can write an otherwise. Okay, this means default. Okay, if any of these conditions are not met, that means if the enable, see, for enable is equal to 1, all the 8 conditions have been met, and then you have if these are not the, if these 8 conditions are not true, then the next 8, for the next 8 conditions, automatically the output will be 0, all will be 0. So you can straight away, you don't have to write this again, for enable is equal to 0 for all these 8 conditions. So with a single command you can program it so that the for enable is equal to 0, everything will be 0. So this is how an decoder looks like. Okay, this is the program for an decoder in Verilog. Okay, now encoder, I think this is not this we didn't do last time. So if you see what an encoder does is, it does the exactly opposite of an decoder, what it does. So if y0 is 1, then you get 0 0 0 out here, right? If you see here, now if y0 is 1, you get 0 0 0 here. Okay, in this encoder also, only one line is supposed to go high. Okay, so if y1 is high, then you will have 0 0 1, and similarly if y7 is 1, then you have a 1 1 here. So this is exactly opposite of that of an decoder. Now how to make an A2 A1? So from here, from these things, you can see that you can write an A2 is equal to, it is OR of y4 plus y5 plus y6 plus y7. A1 is y2 OR of this. Okay, so this can be straight away visualized. These expressions, Boolean expressions, can be straight away visualized from this truth table. Okay, so accordingly I can just write an program. Input is an 8-bit data, and output is an 3-bit data. Okay, 0 to 7 and 0 to 2. This is 3-bit. Out is 3. Okay, and input is 7. Right, and then output, this out, we are using an assign command. So this is like concatenation, right? We learned how to write a concatenation command in the last class. So it is an OR of in4. In4 means that will take the, we are taking in as an a single 8-bit data in, but whereas now here we are taking OR of individual bits. Okay, this is the y4, now y5, y6 and y7. This y4, y5, y6 and y7. So that has been written like this. So this is the code for an encoder. So we can write an encoder like this. So if you take an application of encoder and decoder, so if I say a binary to gray converter, okay, so if you see binary for 000, the gray code will be 000. For 001, the gray code will be 0. So 010, in the gray code we saw that only there has to be only one change which is happening out here, right? So that is the reason in gray code this has changed here, and then it comes to 100. So this data has gotten changed here, and also we say from here to here also there is only change in one bit. So this 0 is 1 is going to be changed here. If you see here, it is the mirror image for it is 10 10 11 11 01 01 0. So it is a mirror image. Only thing is the MSB has changed from 0 to 1. So in this gray code, as we move from here to here, only one bit is changing, right? So how to write a program? So what we can do is, now first we have this data which is available here 3. We make an decoder out here, right? And we are going to connect this decoder, right, and into an encoder out here, right? So again you will get the 3 back. So you have let me do that. So right, now what I am going to do is, I am going to put an okay. So I have this binary code which is coming out here, right? So what I am going to do is, for 000, let me get that table also here so that it becomes easy. Right, for 00 it is 000 here. So I am going to connect an D0, sorry, D0 I am going to connect to Y0 out here, right? And for 1 it is going to be 1. So I am going to give the same 00. If I give 000, this will get activated, and it is connected to 00 here. So 000 will be available out here, right? If I put 001, this will be activated. So I get it to Y1 out here, right? So again 1 will be activated. Then it comes the difference, right? So if I have 001, if I write here, this line will be activated, okay. But then if this is there, I have to get here 011. So I have to connect this D2 to Y3 instead of Y2, and I have to connect D2 to Y2. Okay, so I make a swap out here, right? So this is how if you do the proper interconnections, we will be able to make an binary code here, and you will have an gray code here, right? So if you see here, right, so this D2 is going to be connected to Y3, and D3 is going to be connected to Y2. So there is a swap here, D2 to Y3 and Y2 to. So these data, if you see here, so they are being swapped out here, right? So this is how we write an code for. So here if you see what has been done here, so I have an input, I have an output, and intermediate, and I have an wire out here, right? And then I have an decoder in the decoder, since there I have put an enable also, so I am giving it a permanent enable, right? In the decoder I said I have put one enable also, so here I am giving it as permanent enable out here. And then for the encoder, so this is the output of the decoder. For the encoder, if you see here, it is 0 1, right, and instead of 2 3 I have done the swap out here, right. So this is swapped out here, right. After that, if I see 0 1 2 3, then I have okay, these data also being swapped, right. So these data are also changed. So accordingly, this you have to look at this table and then accordingly swap these data accordingly, right. So you will have to write these values accordingly, so that you get the gray code. Okay, so this is one application. So we'll do the simulation and we'll confirm this. Okay. Similarly, we learnt about mux also, where you given a set of data and you given a control signal. So one of the signals will be routed. If you give 0 0 0, this will be routed out, and if you give 1 1 1, this will be routed output. So this is the code, right? For this we discussed in the last class. So this is mux. So one application of mux we are going to do today is like suppose I have a set of data available here, right, and that needs to be transmitted from say one chip to other. So I don't have to take the entire full lines here. I can just send a single line out here, right, and the control signals out here. So if I give 0 0 0 here, right. So if I give 0 0 here, so whatever is this 0 line, and okay, whatever is the data, it could be either 0 or it could be 1, right here. So that will be transmitted here. So again I am putting 0 0 0 here also. So I have, if you see here, if it is 0 here, this will be disabled, so I will get a 0 out here. If it is 1 here, it will be enabled, so I will get a 1 here. So whatever is this data of this line will be available out here, right. Similarly, if I write instead of 0 0 0 here, if I write 1 1 here, and if I write 1 1 1 here also, so whatever is this data available will be coming available out here, right. It could be 0 or 1. If it is a 0, this will be disabled, so I will get an output 0. If this is 1, this will be enabled, and I will get an 1 out here. So essentially, when we are communicating between these two chips, you don't have to take the so many lines. You can just take the control line and a single line. Okay, that is one more application. So this is the program for that. You have taken here input 7 lines, and this is an mux. So the output is this, and output is D, that is a single line which is available out of the mux. This is the control signal. So output is a single line. That single line you are taking it as an enable signal for the decoder. Okay, and that is how we can do this. So once we do the simulation, we'll see the results out here. So let me create a folder as lab 7. I'm writing lab 7, and let me put in essentially why I make a folder is all the corresponding will be available in that folder, right. And then first I add a new source, so Verilog module. So let me write it as decoder. whatever I just explained, I am putting that out here. So module, okay. So let's do an syntax error. Check for the syntax error out here. Okay, so that is fine. Then let me make an this is a decoder. Let me make an encoder also. What's happened? Okay. New source, Verilog module. Okay. Now make an encoder out here. Yeah. Now let me make a new source. Let me call it as binary to gray code Verilog module. So this is our binary. So let's make an test bench for it. Verilog text bench. Right. So this is the test bench. So input is 0. So let's take all the possible combinations. Okay. So if you see here, 0 0 is the so output is 0 0. Then you have 0 0 1, output gray is 0 0 1. Then you have 0 1 0, whereas the output is 0 1 1 here. Now it is the gray code which is coming here, right? 0 1 1, it is 0 1 0. So this data has got swapped here. Now from here 0 1 1, you have 1 0 0 here. So you have more than 1 bits changing here, whereas in the gray code you have only one. So this MSB is changed, only the MSB has changed out here. This 1 0 has remained here, then 1 1, because this is the mirror image from here, right? So if you see here, the on the top the output is following a gray code, whereas this is the input. So this is how we can make an gray to binary. Okay. Binary to gray. Similarly, you can make gray to binary also. So you can try it out yourself. So this is one which way I wanted to show you. Okay. Then also let's make the mux out here. Source. So this is the mux which we did last time, right? So mux. Okay, so that has been done. So let me just write it as an app one. This is the application which we discussed, right, where we want to transmit only a single line and then transfer the data from one chip to other. So this is that program which we discussed in the slide. So this is app one. I do an okay. So let me make an test for that. Okay, so let's give some all the possible conditions out here. Okay, what I have done here is if you see here the input, okay, just to verify whether it is working, I have given 1 0 1 0 1 0 1 0. That means the input is like an alternate. I have taken zeros and ones out here, right? That is the input I have given everywhere out here for entire. So if I see the waveform out here, so if you see here, okay, input out here is 1 0 1 0 same. For when I am giving a control signal on a 0 0 0 0 out here, right? So D is 0 and the output is all 0 0 0 0 out here, right? If I give a control 0 0 1 out here, okay, D will be 1 because I am selecting the second bit, and input I have just given the second bit as 1. So that is why this is 1 out here, and the output also, if you see here, the second bit is 1 out here, right? And if I give the next control signal 0 1 0, obviously the third is 0 here, so D is 0 and output everything is 0 out here. So if you see here, this 1 0 0 0 0 1 0 1 0 1 0 1 0 is being reflected here also. You have 0, then 1 0 1 0 1 0 1. So instead of transmitting 8 different lines from chip A to chip B, I am transmitting only a single line, which is the D out here, and I am using the control signals to regenerate that particular, right? So if you see here, this is 0 0 0, this is 0 0 1 here. So when I am selecting that particular control line, so the data which is available here is being reflected here out here, right? So this is 1 out here, so that 1 is coming here. So this is what we discussed as one of the applications of using a mux and an encoder together. Okay, so that's all for today. So we'll stop the lab class here. Okay, so